Subtracting polynomials is very similar to adding polynomials in that we are going to be combining like terms and we are going to be leaving it in standard form. There is one more step that we need to add to the beginning, which is distributing the negative sign. So whenever you see that there is a minus sign, you want to take the time to rewrite it with the negative sign distributed. So what I mean by that is we're going to rewrite this just the way it is, but we're going to take some time to distribute the negative sign. That is going to make this negative 3x cubed. If I distribute it here, it becomes negative 5x squared. If I distribute it here, that becomes negative 8x. Be careful in the next one, because if I distribute it here, two negatives would make this a positive 2. So that is the only thing that is added to the process when it becomes a subtraction problem. From here, we're going to be combining like terms just like we did in the addition problem. I will look for the biggest exponents first. I have a positive 1x cubed here, and I have a negative 3x cubed there. So there is an invisible 1 here. 1, take away 3, makes negative 2x cubes. The next biggest exponent is 2x squared and minus 5x squared. 2, take away 5, is negative 3x squared. The next biggest exponent is just x. I've got a positive 8x and a negative 8x. Now positive 8 and negative 8 technically cancel each other out, so I have 0 x's. The only thing left will be a constant, and I only have one of those. There's nothing to combine because I only have one, so that just goes on the end. Now you can leave it like that, and that would be a fantastic answer. If you don't like the 0 there, it is appropriate for you to remove it. So what that means is I will just not write it down, and I will skip to the plus 2. This is probably the better way to write it, but I will give you full credit if that's how you leave your answer.